Hello everyone, welcome to another recreational coding session with myself. This is the second video. I'll continue the um days of learning, day two of learning Go another time. Right now, something caught my attention. So yesterday I was trying to sign up with Twitch, then I realized that they had that username checking thing. So I wondered how that actually worked. And But first, I could actually show you what I'm talking about. So, for example, say you wanted to select a username like Jake. The Twitch would immediately tell you that username is unavailable. Yeah. And it would, maybe when you finally got the unique username that no one had picked, it would inform you. But this happens quite fast. And I feel like it's an efficient process. And I know Gmail does a similar thing with how they use their emails. So, my question is, how do they do it? That's what I want us to try diving into today. So, I mean, let's just think about it in VS Code now. Let's just write stuff. So, first of all, it means they have all their usernames stored somewhere. An easy way of doing this could be storing, an easy and fast way could be an in memory store of all their usernames. They don't have to, it doesn't have to be anything complicated. I'm sure if we were to try something like this, we could use a set. And if username in set, I will quickly respond with username unavailable. That's pretty simple. But there are problems with this. Okay, SIMPLE, I think. There are problems with this way of doing it. If you did it that way, first of all, for something like Gmail, that probably has users in the billions, it's ineffective. Storing so many usernames in memory. Like, nah. Another way to do that would be with an actual database, like maybe SQL or something. But that would involve a database read operation. Assuming a lot of people could be creating accounts at the same time and all those read operations, the fact that you have to actually reach the database, this is actually also ineffective. Because first of all, you have to store all those usernames on some disk and read, which is slow, IO dash slow. So we don't want to do that either. And I did some research, and what they actually use is something called a Bloom filter. Yes, let's actually look into it to see what a Bloom filter actually is. So we can do Wikipedia, right? So let's search Bloom filter. Okay. No, I don't want. I want from Wikipedia. This is taking more time. All right. So it says here that in computing, a Bloom filter is a space-efficient probabilistic data structure conceived by Howard Bloom in 1970, and it's used to test whether an element is a member of a set. Yes. So I guess it's like putting something in a set, but not really putting it in a set. It's used to test if something is in a set. So that makes sense. False positive matches are possible. What this means is that the Bloom filter could be wrong. It will tell us that a username is already taken, but maybe that username hasn't been taken. But false negatives are not possible. What this means is that if it tells us a username hasn't been taken, then it actually hasn't been taken. Okay, so in other words, a query returns either possibly in set or definitely not in set. Elements can be added to the set but not removed. But I guess there's a new type of Bloom filter called the counting Bloom filter that actually does this better. It allows for adding and removing of stuff. So a Bloom filter is a bit array of n bits all set to 0. It is equipped with k different hash functions, which map set elements to one of the n possible array positions. To be optimal, the hash function should be uniformly distributed and independent. Okay, typically k is a small constant which depends on the desired false error rates, epsilon, while m is proportional to k and the number of elements to be added. Okay, I guess we don't want to be too technical about it. But basically, it checks if something is in a set probabilistically, which I guess that makes sense. Assuming we would not have to, okay, so let's say we wanted to follow through with the project since we found our solution. Our solution is a Bloom filter. Assuming, okay, so let's say we wanted to define, let's say, okay, now we are going through the project and we want to actually, we've agreed that we'll code this, right? And we don't want to do this with like in an ineffective way. So we can try to draft up a system for this Bloom filter. Okay, so let's say we have our front end. We have our front end. And a user enters a user name, right? We make some sort of request, but most likely we send the post request to our server. We send a post request to our server. Yes, the request would then hit the Bloom filter. The Bloom filter would determine if it's in the database, meaning this username has been encountered before, or someone already has that username, or if it's not in the database. But remember, from the description of Bloom filters, they have an error rate. So to account for this error rate, when we've gotten this answer, all we can do is from this point, we will then pass another request to the database to actually check if the username is available, meaning if the username does not already exist in the database. But that's only if the Bloom filter says that no, this username has not been encountered before. Because we have a false positive rate, we still have to verify that ourselves. So because for a system like Gmail, I assume that a user's Gmail is actually a database key, so we can't have duplicates. So we would have to check if the Bloom filter tells us that it's not in the database. We'll have to cross-reference with our database because it can have false negatives. Sorry, it can have false positives telling us it can have false positives telling us it's not in database when it's actually in database. Oh, wait. I think maybe I'm making a mistake. Let me check the definition of Bloom filters again, please. Permit me not to be confused with Bloom shader effect. In computing, a Bloom filter is a space sufficient that is used to test whether an element is a member of a set. False positive matches are possible, but false negatives are not. In other words, a query returns either possibly in a set or definitely not in set. So if the Bloom filter were to tell us that it's definitely not in this set, we would believe it because it can't have false negatives. But if it tells us that it's possibly in the set or in the database, then we'd have to go and check the database again. Okay, so I would have to make some corrections to what we drafted out. So that means the user makes a request to the front end, enters the username, we pass a post request to our server containing that username. It goes through our Bloom filter and maybe tells us the username is possibly in the set. So it's in the database. And for this type of request, it can have what's it called? False positives. So it has an error rate when it tells us that something is in the database. Now, to prevent this error rate, at this point, what we would then do would be to actually check the database, meaning make a database read request. Because we assume the username or the Gmail or whatever will be a key in the database, so we can't have duplicates. But if it tells us that it's not in the database, it means that the name is available, and we immediately return to the user. So, okay, we can match. Okay, so depending on if the answer is in the database, we confirm. But if it tells us that it's not in the database, all we can do is we tell the user they are good to go, which makes sense. Okay, so I guess we can run through if we were to build, and we're going to build a very minimalistic version of this, a very small scale version. So let's say from the front end, which can be maybe the Switch UI, a user enters the username. We make a post request to the server. It doesn't hit the database, rather it goes through the Bloom filter. If the result from the Bloom filter tells us that, okay, this username is possibly in the database, it may not be correct. So then we'd have to actually check the database. But if it tells us that it's not in the database, then we just believe it because then it's not in the database. Huh. I don't understand. Am I still getting this correctly? Wait, I have to read this again. Wait, let me actually, maybe I'm mixing my understanding up between false positives and false negatives. So it can tell us it's either possibly in the set or definitely not in set. Once again, when it tells us that it's possibly in the database, yes. When it tells us that it's possibly in the database, we go to the database to check if it's actually. Oh, am I feeling the system? If it tells us that it's possibly in the set, yeah, we actually check because we can't go by possibly in the set and allow the user to not get. Oh, means there are more than one way we could actually do this. We could actually just tell the user that if we say it's possibly in the set, we could just outright tell the user that this username has been claimed, even though it has not been claimed. Then the user will have to come up with something different. And if it tells us that it's definitely not in the set, we can tell the user that indeed the username has not been claimed. So okay. Okay. So we can do. I understand what we can do. So I'll say I'll use the nomenclature they use there, possibly, so that I can easily understand what I'm doing. Possibly in the set. This is a false positive, which could be a false positive, meaning maybe the username may indeed not exist, or it tells us that it's possibly in the set. Then it can also tell us that it is definitely not in the set. So definitely not in the set. Okay, so we can actually go in two ways. If it tells us that it's possibly in the set, we could actually confirm by going to the database and checking ourselves. And if it tells us that it's not in the database, or let's say if it tells us that it's not in the set, it tells us that it's not in the set, we could just tell the user they are good to go. Or if it tells us that it's possibly in the set, what another thing we could do is we could just keep this process, and whether it tells us that it's not in the set or possibly in the set. Okay. If it tells us that it's in the set, it means the username is available. If it tells us that it's in the set, we check the database and then inform the user that this username is either if it's available or it's not available, or not in the set, and tell the user they are good to go. I'm still struggling to understand if I'm getting it correctly. Man, I feel like I should have done more research. And I don't want to end the video. When it tells us that it's possibly in the set, we could either check the database to see if it's actually there, or just go by its answer, because maybe the error rate is acceptable. Okay, now, so we have to actually talk about the error rate we are willing to have. Say we're allowing ourselves to have like an error rate of 0.01, This would mean that 0.01% of the time, it will tell us that it's possibly in the set when it's actually not in the set. And this would cause us to check the database.
A few moments later.
Okay, since we've kind of defined what we are talking about, which actually works, which should technically work, the design should work. We only read the database if we get a possibly in set. This minimizes yes, database reads. So yeah, this should work. Now, if you wanted to code this, because I'm pretty sure we don't have to code one from scratch. We could pick a simple tech stack. I'm familiar with Node.js because this seems like something you do with the backend. Before I embarked on this, I was thinking, how should the front end be or whatever. But I realized that life is not that deep, so we just used Postman, then MongoDB. Yeah, that should be our tech stack. But first, let's see if we've got something like some npm package that can help us. Npm. Let's see. Bloom. So yep, we've got one Bloom filters. Okay. So this is just, so you just import the Bloom filters. You generate a new Bloom filter, but we don't know the. Okay. Let's check documentation. The arguments. I think the first one is the amount of bits, and the second one is the error rate, I believe. Okay, we are now at the very bottom of the page. So let's make our way up. Okay, let's see. Okay, yeah, it says here create a Bloom filter with a size of 10 and okay, size of 10 and 4 hash functions. So this is we instantiate a Bloom filter with a size of 10 and 4 hash functions. Then we add Alice and Bob to it, output true, output false. Okay. We are logging the error rate here. Okay, so if we did bloom filter.create, we could pass in our own error rate and the number of items we want to consider. Okay. Okay, so I guess we could use this bloom filters package. So I've already stated this text stack, and we've seen the package we are most likely going to use. So let's npm install everything. Let's get my terminal to wake up. So that would be the first command would be npm init to get the package.json and stuff. I guess I'm going to have to edit this video to cut out the fast parts. I don't want this to take too much time. Package name, yes. Oh, I should have done -y. Whatever. Yes. Okay. npm I bloom filters express. What else do we need? Mongoose. This should be enough stuff. Okay. Taking more time than I would like. But I guess we can just start. We can create some index.json. Oh no, not .json, index.js. I need to rename this. This would be the entry point of the program. So import, and we'll use this ES6 syntax: import express from express const server equals to express. I'm not using .env or anything fancy. Const port is equals to 3569 server.listen. The listen on almost forgot to pass the port. PORT. Can't believe these node modules take such a long time. So listen port console.log on the thing on ports, listening on HTTP, right? This is the syntax, if I'm not mistaken, localhost ports. Then we can import mongoose as well while we're at it. So we can just connect the database from mongoose. Okay. Mongoose dot. Sorry, that's not what I wanted to do. Yes, it is what I wanted to do. Mongoose dot connect. Oh, we can do that like here. Server dot use express dot JSON. This is body, basically body parts on middleware. Okay, port. Let's say this is the express application. The fact that this npm download is still going on is crazy. This is the port. Let's set up our bloom filter. Now we have to create a module or model, a database model for the user. So we're going to use that.js. It's just a database model. Import, what is it called? Schema from mongoose. So we're importing the database schema. From mongoose. No, import the schema object. Now we can define the user schema. Const user is equal to schema, I believe. Question I always have is if new is needed when you're using this. Is it new schema or is it just schema? Okay, I guess it's new schema. Okay, the npm stuff is finally done. So user schema is what this would be called. I'm going to have some simple stuff. Basically, the only thing we need is username, which is of type string and is required. Then const const user. Okay, yes, that's what I wanted to import mongoose. We have to import mongoose because what we'll do is mongoose let's see dot schema, which would be, I think this is the code. No, it's mongoose.model. This is funny. Is it capital letter M or small letter? I don't even remember. So that user schema. Come out the name of the model, which is user. I believe it. But if we make a mistake, it's error. So we export the user, export default user. Then in package.json, we set the type to module. We can download npm i-t node-mon. Then in the dev script, wow, we had a problem. Okay, it's because I'm typing. Okay, no problem. It's not a problem then. Node-mon index.js. Then we can try this again. So it should work this time. Then we can have, yes, we can instantiate the database in the index.js page. Did I? Okay, maybe it's not dash d, it's dash save dev control. How do I exit? npm dash save dash dev. So hope I didn't break anything. Okay, is it dash save dev or dash save dev? I don't even remember. But we'll see. If it's wrong, I'll have an error. Yes, so now we want to connect the database. Connect the database. Mongoose. Connect. Or maybe we should have a separate database connection file. Okay, so we'll create a separate database connection file. I guess I'm not used to talking while programming. Okay, so let me think. db connection .js import mongoose from mongoose. Okay, so mongoose connect. I'm just going to hard code this, the URI. Don't think I remember local http. 2017 or something like that. Let me ask Copilot. Write the MongoDB connection file. Okay. I think this video is already very long. I'll be right about, yeah, please. How do you Oh my god, it actually uses MongoDB. I've totally forgotten that. Wow, I think Copilot had an update. Because now they just put the code in without my permission. Normally, or is it a different mode? And this is too complicated for what I even want to do. What is the meaning of this? Okay. And it also, I think it's because it's in agent mode. It's ask mode I want to use. Now I want to install. This is the thing. You tell it A, it does B, C, and D for you as well. This is why I don't like. I'm not really a fan of it. I created an env file. Oh. Then I'm turning it off because all I wanted it to do was the database connection file. I wrote too much. All these details are not needed. Like his neural parser has been deprecated some time ago. All these details are also not needed. My God. Okay, it probably thinks I'm using bash. I'll just do it myself. npm i.env. This is so overwhelming. Oh wow. Well, I mean, you threw a wrench in my plans, but whatever, I guess. So npm run dev, let's see where we are. Run dev. We still need a router. That routes stuff. Yes. Okay. Oh, so my God, did you write this stuff twice? Look at the AI's handwork, and this is what is going to take our job. Fantastic. Okay, I think maybe I should be playing some music that I can also hear as well, because the music I'm currently playing, only the video gets the music. I don't get the music, and I'm bored already talking to myself. Okay, but let's go. So where are we? Okay. Yes, now we'll have to create a router. Router.js imports router from Express const exports the no. Okay. Router. So we create a new router. Let's go. This has taken too much time. Const router. Router.use right. API availability API yeah, export default router. So now we export the router, we import it in the index.js and connect it. Import router from router.js. Use the router. Server. Use router. Is this even correct? I don't even know. Okay. Man. Yeah, I don't think it's correct. Okay, yeah, it is correct. Let's see. Our router needs a handler and pass the function. I can make it an asynchronous function. Let's see. So I guess now the error should be gone. Yeah, the error is gone. The AI added another deprecated something. Okay, but whatever, let's go. So this is request, response, next. We can import the bloom filter here. The moment we've been waiting for. All these have just been filler episodes. Bloom filter from bloom filters. Yes. So const filter. Const filter. I'll change this from agent mode to ask. I don't believe you guys can see what I'm doing right now because my username is probably, my image is probably blocking it. But I just changed Copilot from agent mode to ask. I usually don't use this in agent mode. Actually, this is the first time, and I'm surprised it was even in agent mode to begin with. Filter new bloom filter. Let's see if we wanted to support 100,000 users and 7 hash functions of 3. Okay, no, maybe 3 is too small. Maybe 4 hash functions. So now we have a new bloom filter. So to check if something is available, yeah, we're gonna take a quick break, then I'll get back.
A few moments later.
Okay, I'm back from my quick break. Yeah, so what I want us to do now is we can take this Bloom filter and put it in its own file. Once again, it feels like I'm talking to myself. My God. Okay, so we can put this in its own file and import it. Control C. Let's get this out. So okay, we get this out as well. Control C, remove this. So create a new file called bloom.js. Then this and okay, then just export the filter. We can use it this way. Export the defaults. Export default filter. Then in the handler, in our router, where's the router? We could just here we could import filter from bloom.js. Then we could decode the request body. We decode the request body. The only thing a request is going to contain is the username because that's the only thing we're interested in. And this is just a short demo tutorial. What's the request? Wait, this is not a tutorial. I wouldn't call it that. Body is a property, not a function. Filter.has. What does returns a boolean username. Okay. Let's in filter close to filter that has username. Oh, what we can do for this? Control C. We can put it best way, error handling, try catch, error. And usually I would have a middleware that I could pass it to, but we can just, rather than throw in, we can return response.status, ES status can be 500.json. Usually an actual project would look much better than this, but this is not a project channel. Message, not message, success false. Success is false. Message, error code. Let's see if error.message is present. Maybe, I don't know, remember if they have a message object. Then we can paste this again. So filter.has username checks if we have this username in our filter. And if we go back to our details file where we actually thought of what we were going to do, we can see that the flow is as follows. From the front end, we can enter username, make it, which is a push request to our server. Okay. And it passes through our Bloom filter first. If we see that returns possibly in sets, meaning the username, we may have the username, then we decide to check the database. If it returns not in set, then we don't tell the user that it's good because there are no false negatives or false positives are possible. So we read if we get possible in sets, which in this case would be true. So if this is true, if in filter, because in JavaScript you can just do this. This actually doesn't work in Rust. True has to be true and false. There are no truthy and falsy values. And we can put this in the comments. This is truthy. CRUTHY. If this is truthy. If this is okay. This place it returns boolean, so we can just say this is true. In filter, then we actually make the database read. So we have to import the user model. Yes, then we do await. That's why I made this async. User dot find. So is it find one, which is in this case pass the username as the key that we are looking for, which is okay, we can just pass username then because it's the same. So we try to find the user. If the user is not a null value, it means that indeed we have this in the database. So if user or return response.status 200 no, so yeah, 200 is success.json message success. It's like there's an error in the code. Let's see. Wow. So what's the problem? Syntax error, unexpected string success. This would be true. Message username unavailable. Else, if the user is not in the set, meaning if this returns null, so we could do else here. Else if this returns null, rest dot status. So what's the status? 200.json. In this case, you could do success true message username. Available. Or we can just do availability true, availability false. Available, this will be false. Here available will be true. Available will be true. Then outside if filter we will just run, because if this is not true, it means that it's definitely not in the set. So this is possibly in the set, else this is definitely not in the set. Not in the set. That would be rest dot status 200 because the request didn't fail.json. Success true, available false. Now time to see if there's something I'm missing. Yeah, this crashes. Named export bloom filter not found. Huh? Okay. In bloom.js we have an issue. Okay, let's see how it's done in the browser. So wow, this is crazy. Because here all they do is just const bloom filter equals require bloom filters. So they extract it. So what's the problem with the code then? Let's see. Bloom filter. Okay. Bloom filter is a common JS model which may not support all module exports as named exports. But if we did that, means we'll have to change the imports everywhere. This is just terrible. I mean, we can import everything and do bloom filter or filter.bloom filter, right? Okay, so we can do bloom filter dot new bloom filter dot bloom filter. That way we don't have to. So let's see if it works. And just wish it would be faster. Oh my god. This set schema is not a function. And user.js. Okay, mongoose. Okay, let's see. I made a mistake here. Mongoose model, user schema. Then is it mongoose model? What am I getting wrong? Still, this isn't it. Let's see. Yeah, I got the parameters mixed up, or the arguments in this case. I feel like I'm still missing something in the overall architecture that will cause this to fail. I guess there's no point for a next here because I'm not passing it an error, so I can just remove this. I feel like there's still something wrong, but let's just get the postman something. Sorry, no, get the postman extension and see if it works. Postman. Trust permission install. Okay. In the meantime, I'll give it the context of the workspace. I'll ask it to create a script that fills our Bloom filter and MongoDB with usernames should match. So this is installed. Meanwhile, I'll have Copilot busy. And this still says installing. So I guess we could just look through our code. So here we extract the username from request body. I mean, comments like these I actually use as request body because they're self-explanatory. Check if your username is in filter. Huh. How long has this video taken so far? I'm tired. Let's see. On the bright side, this thing is done. And this is going to have to be an independent file. Yeah, populate data.js. And we'll have to run it. So turn this off in the meantime. Delete import the filter. Yeah. That's why I made the filter and import in a separate page. We could just import it and fill the same filter with stuff. What is it asking for? So it asks for an argument. Let's see if it gives us an explanation of the code it generated. Okay. So this script creates a comprehensive data population utility that generates unique usernames, uses combination of adjective nouns and suffixes to create relative usernames, clears existing data, removes existing MongoDB entries. Yeah, note, Bloom filters can't be easily created. Batch efficiently inserts usernames into MongoDB in batches. Adds all usernames to the filter from Node.js. Tests both data stores to ensure consistency. Shows real-time progress during population. To use these scripts, we run Node with the amount. Oh, I have to sign in the postman. I'll edit this part out. Oh, let's just back out. I didn't know I had to sign in. Then I'll just use my original postman. Because what's the point? Oh, I should have done this ahead of time. But Jesus Christ, how long would this thing even take for such a simple project? I should have project outlines for now. Okay. Fantastic. This is the Postman workspace localhost 5690. No, so first of all, let's populate the database by doing node populate data.js. Node on the give unit 5,000. The default count is 10,000, but we'll do 5,000. And I want to edit the bloom filter. Here it is, bloom.js. Okay, we just passed the filter, we didn't really do anything with it. I believe this has size. But does GPT's code account for the mistake we made? No, I don't think it did, because this should be set as initialization. So what we'll do is, in the bloom.js, we did set, let's say we said 5,300 and 4 hash functions. Then now let's populate and see how it goes. Okay, so this is why I don't like AI. It overdid it, but at least has given us some sample usernames you can use. Okay, so now what we'll do is we'll initiate npm run dev. Then we'll save these things to know if what we are doing is anywhere accurate. We'll save them to details.txt and we'll use them. Melvin. Okay. Now let's look at new HTTP request. Fantastic. Poof. Okay, so now we can test this. We are using localhost HTTP localhost 3569 /API /executability body. We want some raw JSON. We just sent username. And we have examples of usernames that shouldn't be in the database. Okay, so let's try this username. The filter returns true. True refers to this could possibly be in the set, and the database is already. Okay, so let's see. Send. Let's see what errors I get first. Cannot destructure property username or request body as it is undefined. Which is crazy because. Okay, this is a get request, not a push request. So I was about to shed tears of annoyance. I knew there was something wrong with this code. Okay, I guess the thing is rebooting, but let's see. My God. But for my second video, this is quite long. Oh, Jesus Christ. This could just be a test run. As soon as I figure out what's happening, I'll probably redo this video tomorrow. Internal server error of requested body. Oh, okay. This is a live you learn moment. I have something to do right soon. Oof. Sending it multiple times won't change the results. It's telling me it can't destructure username. So what does the request body con? Then let's just console.log the request body. Request of body. So that I can know what's going wrong, because at least we know it hits our target. And tells us cannot destructure property username because it is undefined. It means it has stopped here. Won't come to this next code point. My bad. This has been a disaster. I will do this tomorrow. Yeah, you get to learn the tools you're using.
A few moments later.
Okay, guys. After debugging this for what feels like forever, which was maybe 40 minutes or something, the problem actually was not in our code. The problem was the Postman extension. I don't know what it was causing or whatever, but it wasn't allowing the request to pass through with a viable request body. I was about to give up on being a developer internally and just, I don't know, go home, put the fries in the bag. But apparently I don't need to put the fries in the bag yet, because it wasn't technically our fault. But I found out that when I was looking through the code, we made some faulty assumptions. When Copilot originally generated the populate data code, what we did was we ran the code outside of the main running server. We had a faulty, or rather I had a faulty assumption, which was that Bloom had some sort of external memory. No, Bloom doesn't have any form of external memory. Bloom is the Bloom filter is stored in memory. So if what we did by doing node populate data.js 5000, when we did that, it would populate the data, then immediately exit the program. So our database, our MongoDB database will be populated, but our what's it called? Our Bloom filter would be populated, then immediately the program ends, all those data would then be lost. So I of course made this happen within the code. I just asked the AI to create a fill Bloom function, and then we do it immediately the server is online. That way it's using the server's memory. So that was one change I made. Or I also added in the router.js page, I added reasons for, okay, like if we get a possibly in set, we have to check the database to know if it's in a set or not. This is an optional step. You can decide to go purely by what the Bloom filter says, but I decided against that. But to actually check the database, although it's less reads, you still read more often than not to check if the username is actually available or not, because it will tell you that it's possibly unavailable, meaning we've seen it before, but it's capable of drawing false positives. So we still have to check the database. And if we check the database and find out that a user exists in database, meaning the username is taken, we say available is false, and we give a reason username exists in database. And username exists in database. But if the username doesn't exist in the database, what we could have done here, we could have said set available to false, because it conflicts with the Bloom filter, but I set it to true and told them that the reason flagged by filter but unavailable in database, meaning the filter made an error in its guess. then if the Bloom filter didn't tell us that it was possibly in the set, it means that, oh, the username is definitely available. So it's definitely not in the set. Then we just return true. And anytime we restart the server, it populates the database, not the database, the database is already populated it. So it just populates the, already, like it says, found 5,000 usernames in database. So it populates the Bloom filter instead with usernames like this, like Faster123, Mage2K, Superbeer, and stuff. So if we were to try some common usernames, either it would be, for example, if we tried Mage2K, maybe to tell us something like username not available. So let's go to Postman and see this. For example, we tried Mage2K. The request would go through and tell us the username is unavailable as it already exists in the database. So it means that what the code did was basically it followed the flow that we thought of it initially. It follows the flow. So we send a username from the front end, passes through the Bloom filter, and if it's in the Bloom filter too, possibly in sets, we chose to check the database to confirm due to false positives, due to false positives. But if it told us definitely not in set, it means we wouldn't check the database and we would just tell the user that the username they picked was available. So available would be false. Available would be true. Would be true. So sorry, that's not the spelling of true. So we can try that by doing available true for a name like let's try something like Jason Vores 678. This tells us that this username is available. So here it just focused on the set, it didn't hit the database. So we didn't have to do an unnecessary read operation. Yeah. Yeah. So yeah, that's it. We can try other usernames to see how it actually works. Yeah. So I guess we're done. We're done. We achieved the flow that we talked about initially. But to really know if it works, you have to try some other usernames, like Wildcat34. Okay, this username is available. Yeah, username is available. Maybe try something like Frozen Obstacle 23. Okay, this username is available, but I think there's something similar to it as the filter flagged it. But because of the false, there are probable false positives, we still made our way to the database to actually confirm. Yeah, so that's that. We can actually say that we achieved the goal of the video. So I guess we could recap the code. Let's do that. Let's recap the code. Okay, so basically this is the process that we were going for. So from a front end, we could enter a username and to send a push request to our server and go through the Bloom filter. If the Bloom filter tells us that it's possibly in the set, then we would check the database due to the false positive rates. And if it tells us that it's not in the set, we don't make the database read and we just go straight to the task, which increases, I guess it could increase database longevity if you're doing so much reads. That's one thing. And it also makes it much faster. Oh, let's actually check the difference in speed, because I know we could see that in Postman. The difference in speed between sending out requests. So for this one that went to the database, it took it like 56 milliseconds. Okay, let's now check JSON Borers once again. That isn't in the database. Let's try that. JSON EORE S2345. Let's see. It's indeed faster. This time it took 16 milliseconds. It waited for about 12.27 milliseconds. So we can actually just see 12.27 milliseconds, which is a lot faster. So than if we tried names that actually. Oh. So JSON Forest did go to the database, but this was still very fast. I guess it's because it's on machine. I want to see something that isn't there. I think we tried Wildcat. Wildcat was not there. Let's try Wildcat again. I want to actually know the speed difference. Wildcat 300. I'm looking for something that will not hit. Human frying pan. Yeah, this here, this is quite fast. This took only 2.80 milliseconds of waiting to receive the request. So I had a 7.69 millisecond wait time, which is very fast. So when it doesn't hit the database, it's even faster, which is actually as expected. It just hits the memory stored Bloom filter and just pops out, which is nice. So I guess that brings our session to an end. This took me longer than I would have liked, but at least we achieved it. Yeah, glory to God. So I'm gonna just close the data, close everything, and git init initialize the Git repository. Git add all files. No, wait, we get ourselves a git ignore. Okay, add all files. Then git commit. And we'll call it. We'll say final first and last commit. No. Semi finished product. I'm done with this. Yeah, at least we've tested out Bloom filters, which is not bad. So I'm just going to publish it as a public repo. So I guess the link will be with this video. But yeah, thank you all for watching. I learned a lot. I also learned patience from debugging. But yeah, have a nice day and see you in another video.